This is a problem from section 2.5. It is about solving and graphing a polynomial function. So, for example, given that f of x is equal to the polynomial x cubed minus 3x squared plus 4, the first thing we will do is find the possible zeros. Now, I take a look at the factors of the leading coefficient and the factors of the last number in the polynomial. So the leading coefficient is 1. So the factors of 1 are plus or minus 1. And the factors of the last number, which I'm calling p equals 4, the factors of that are plus or minus 1, plus or minus 2, and plus or minus 4. Now, there's a few other possible zeros, and these are the fractions that you can make with the factors of q over p. So plus or minus 1/2 and plus or minus 1/4. So these are not the actual solutions, but these are possible solutions, or zeros. Okay, in the next part, I'm going to guess and check to find the first actual solution, the first zero. And I'm going to do that by trying one of the factors, one of the possible zeros that I got on top, and plugging it into the original equation. So I will try x equal -1. So I'm going to plug in -1 into f. And this gives me 0. So what that means, when I work it all out and I get 0, is that x equals -1 is a solution, or a 0. And also I can say that x plus 1 is a factor. Remember that every time you put the solution in as a parentheses, you got to change the sign. So we now know one of the solutions for that function. Now, there's a few other solutions, and that's what I'm going to do next. So let's see. So in this next part, part C, I will find the other solutions using synthetic division, and I will also use the solution that I found by guess and check. So I'm going to put -1 in the little box and then use synthetic division. Remember to put placeholders. So I work it out and I get a remainder of 0, and that's important. The remainder has to always be 0 if you know that if you're using one of the solutions in the box when using synthetic division. So anyways, I got the 1, -4, and 4 in synthetic division. These are the coefficients of this new polynomial. So it's x squared minus 4x plus 4. And the next thing I will do is I will factor this smaller polynomial. Set it equal to 0, factor it, and solve. And I get that x is equal to 2 on this smaller polynomial. And let's remember the original solution that we had by guess and checking. And that was x is equal to -1. So this polynomial has two solutions. The x equals 2 is actually a solution that repeats itself. So I don't have to worry about saying it twice. Okay, so now I know all the solutions, or all the x-intercepts, or all the zeros of the function. They're all the same thing. Okay, now the next thing that I will do is factor the polynomial completely. And so everything is in parentheses. Remember that x equals 2, when put in parentheses, it changes the sign. And also remember that that particular solution is a repeating solution, so it's x minus 2 squared. And so it's fully factored. And I'm going to use this factor form for graphing. And so when graphing, it's going to be important for me to know the degree of the polynomial and the leading coefficient. And so n is equal to 3 is the degree, that is the highest exponent. And then the leading coefficient will be a is equal to 1. Now that's going to tell me about the tails of the graph. Now the middle part, I have to find these k values. And for the k values, let's see, I'm going to have two k values, one at each intercept. So I have k at the x-intercept -1, and I have a k at the x-intercept of 2. And what k is the exponent and the individual parentheses. So the parentheses at -1 has an exponent of 1, and the parentheses that gives me a solution of 2 has an exponent of 2. Okay, so in class we also learned that when k is equal to an odd number, that the graph or the curve will cross the x-axis, and when k is equal to an even number, it will bounce. So I'm going to use those facts as I graph this polynomial. So I go ahead and I plot the two x-intercepts, -1 and 2. And then I use the n equals 3 and a equals 1 to give me the tail ends. So n equals 3 tells me that it's that the curve at tails are going to go in opposite directions. N is equal to an odd number. That always happens. The tails go in opposite directions. And now the leading coefficient is a is equal to 1. You can think of it as like a slope, and so it's positive. And so this curve is going to rise to the right. So to the right of 2, it goes up, but on the far left side, left of -1, it falls down. So that's what happens at the tails. Now, what happens at the middle? For that, I will use the k values. And so at the x-intercept of -1, it crosses. So it crosses there, but at 2, at the x-intercept of 2, it bounces. Now, to have a little bit more of to have a more precise graph, I'm going to see what the y-intercept is. And I will find the y-intercept by setting x equals 0, and I get that it's equal to 4. So 4 is the y-intercept. And so this graph has the x-intercepts and the y-intercept, and that's what this is a good sketch of the polynomial. And that is that.